Okay, have you ever seen threaded rebar inserts? Watch this. That's a big piece of rebar, like 1.1 inches. And see, he's twisting it in? He's twisting it into threads. Look at that. There are threads cut on the rebar and threaded inserts in the precast concrete column. What it effectively does, it makes the continuous bar around the perimeter continuous, into the columns, out of the columns, and across the beam spans. This is a fascinating video. Maybe the most streamlined example of precast concrete structure assembly I've ever seen. It's on a channel called Real Maker. It's a Korean channel. Go there. Look at what they do, subscribe, and let them know that the Yanks could learn a lot from how these boys do precast concrete houses, apartment buildings, whatever this is. I hope that you enjoy this video because I can tell you this, I certainly did. All right, so this is the neighborhood that they're putting a precast concrete building up in 2 weeks. Wow. And that's got to be the precast plant. Yes, different location, different, okay, forklift, moving in forms, edge forms. Okay, and they've got the deck, the table to pour on, up about knee high, cleaning off the scale, locking the edge forms in place with vice grips, and then permanently bolting them together. Seems like they would have a cordless for that. So they're not showing us snapping out the dimension on that big bench, but all right, form release, we understand that. Keeps the concrete from sticking to the steel. Rebar hairpins, okay, coming in from the edge through those slots. I don't quite get that yet. They've got some sort of a method to hold those in place. Okay, there's the method right there. Okay, they pull those hairpins back and just wire them to that piece of tubing. Slick. Automatic rebar tires. Here comes the pre-cut bar. Looks like about number 4 bar, 1/2 inch, scattered on the bottom mat. I assume there's 2 mats. Boy, that's a time saver. All right, so you see that, those pre-bent wires? He fishes through there because he can't get his automatic gun in. Okay, let's hold it right there. That picking eye I mentioned, you see that? There's some sort of a steel loop. I'll call it a clevis. It's not a clevis, but there's some sort of a steel loop inside of there that is one piece or welded to that little upright that's welded or connected to those little pieces of rebar at the bottom. So the crane will be able to drop into those picking eyes and lift this thing up off the table. Very important. Got to be in just the right spot. Got to be strong and wired in. You don't want them to move when the concrete's washing them around. So that's the thing. We're going to see that in a minute, I'm sure. That concrete, when it's being pumped in or poured in, tends to wash or push rebar around in the same way that it'll push forms out of line. It'll wash rebar around. You got to be careful of that. So this mat's just laying there, not tied. Okay, those blocks. I mentioned dobies. Those are spacer blocks that are made out of concrete or a mortar mix that are strong enough to not weaken what's going on right there and hold the rebar in its position. Those picking eyes are awesome. Nice camera angle. Seems to be a hump right there over that dobie. That's not good, but it must just be an optic. All right, they're pouring that. Look how he's signaling that truck back, just waving his hand aside. Look at that. Not the way we would do it, but effective. All right, that loop in his hand is for picking rebar up. 3/4 inch rock or equivalent, pouring around the picking eye. I don't know, what is that? Probably a 4-inch slump. Almost buried that picking eye, boys. I like those leggings, long trowel. So there was no sign of floating. They just got it in place, screeded, and then they're going over it with a steel trowel. It doesn't have to be nice. It just has to be nice enough. Wow, look at that. Wintertime in Korea, but they're enclosing it. That is cool. So they're going to heat it in there, I assume, protect it from freezing for a week or 10 days or something. So that's something about concrete. Concrete setting is called hydration. It's a chemical reaction. And the hydration generates heat. I mean, the heat grows. If you add heat, it sets faster. As the heat dissipates, this hydration slows down. And so if you pour on the grade, on the ground, outside, you're generally good down to, 28 degrees maybe for the first 3 days, because the concrete's making its own heat and it's sitting on ground that hopefully is 52 degrees, unless the ground's frozen. Never pour on frozen ground. So in Korea, they've got to be able to control that. All right, now I am vaguely aware of, you see that heater? That's a space heater. I don't know if that's propane or diesel, but I've heard of something called carburizing. I think that's right. Correct me if I'm wrong, but you increase the amount of carbon inside there with the carbon monoxide or dioxide or whatever the byproduct is of the heaters, and you can contaminate and weaken the surface of the concrete if you're not careful when you heat over the top of a pour. These guys undoubtedly have that figured out. There's the cameraman in the background. 6 mil visqueen keeps us working. Wow, look at the blockouts for plumbing, chases, openings. Okay, they're pulling back off of that. Pulling off the vice grips that are clamping the edge forms, cutting the wires that are holding the rebar stirrups. Out comes the tubing. And what now? Lay the tubing off to the side. Okay, they're going to lift that thing out of there. So these are the male side that drops into those picking eyes. Look at that. Okay, knocking off the scale. Not sure what that was. All right. That drops in and scoops the end of that Nelson stud looking thing. Look at that. Bam, takes a 4x4 and just knocks it off of there. It has to slide down off the hairpins. Easy, buddy, you don't want to bend that. Somebody will yell at you. Wow. All right, so I'm going to guess here. So they undoubtedly accelerate the mix. I don't know if they use calcium chloride or what they use, but to speed up the reaction, because it has to come up to sufficient strength to pull out of those forms. And you can't tie up your whole plant for 21 days, which is often the timeline for stripping a suspended slab or something. 21 days is, I'll make this up and say 80 or 90% of ultimate strength. So we did a shop tour a year ago of Stone Age concrete table tennis. Lem James has got a dynamite little outfit, and they precast a very finished outdoor games. They make games, ping pong tables and foosball tables, and they get their precast concrete hard enough to strip, I think like in 2 days, something like that, with admixtures. So undoubtedly, they are accelerating the rate of the set on this so their tables can be stripped in a timely manner. If anybody knows, let us know how long these things sit there before they can be picked up from those 4 points with those 2 mats of steel and transported over to be stored until they are brought to the site. That's a critical component for them. All right, now they're putting stickers on there, stacking the stickers one above the other so the load transfers down, and it's, oh, look at that. Look at those panels. All right, now we're on site, apparently, and look at that excavator. It's a rubber-mounted excavator clearing off the brush and the debris, scraping, got a clean-out bucket on there, looks like about a 4-foot bucket. I'm surprised at how little rocking around that machine does on rubber tires. Okay, I don't quite get this. Visqueen down on the grade of the dig, the whole thing. And those must be radiant heated floor lines or something? They're just pouring on the visqueen with no rebar in it? Okay, I don't get it, boys. Raking it around. It's just okay. Okay, there are rebar dowels driven into the grade, 2 grade? Is that what that was about? Mud rakes, looks like, okay, those red spots, pause right there. I assume those red paint spots that they've painted after the mud got around there, they appear to match with the red marks on the side so that they can find their grade pins. And they're just screeding eyeball close. What is that, 5 or 6 feet apart? All right, this is a couple days later. Boy, that concrete is not very hard, but they put that anchor in anyhow. See how it's spalled around the drilling? And then there's that raised grade right there. Tap, tap, tap. A little mushy, boys. What is up with that right there in the middle? That must be an area that does not... Oh, they have raised, harder areas. I didn't see those go in. 2, 4, 6. Somebody explain this to me. I lack wisdom. 4, 5, 6. So that rat slab was just put in eyeball close, but these little raised areas must have been shot in very close. Pinch it over. Need a Burke bar, boys. With PC. Precast, with precast. In English. In English. Those are not steel toes, as if those would help. All right, floor beams. Blockouts to receive other joists. Penetrations to receive bolts where they bolt together. Tightened up. Bolting the precast concrete together. Adjusting the length to line up the bolt holes, bingo. So they must, wow. Got clearance over the rat slab. I call it a rat slab. And they're not wasting any time. Expanding foam between the beams. All right, now what is that? Over those bolts. That, is it just mortar? Just mortar mix, I guess. Yep. Just troweling in some mortar. Mostly we're just keeping bugs and rodents out, I would think. Excavator's still working. Yeah. Okay. This whole thing is buried. They got to compact it better than that. Okay, hold that. There had to have been an elaborate grading and compaction process on that. Had to be. I don't know, the excavator's still sitting there. 6 mil, looks lighter than that. What do you got, buddy? Foam blocks, insulation. Yeah, look at that. Okay, so the foam on grade. We do that around here somewhat. And the idea is that ambient earth temperature is 52 degrees. But if they're heating this floor, and I assume that's what those big black pipes were back, 5 minutes ago, you have to insulate between the bottom of a heated slab and the top of unheated ground. And that appears to be 6 inches of some sort of a foam that is strong enough that the load rating on the slab won't care that it's on foam. I mean, it's compressive strength. I don't know what it is, but this foam is not, it's not your grandmother's foam, right? It's pretty good. And then some way, everything has to be tied together. All right, okay, see what he's doing there? He's got the end of a spud ratchet, and he's popping plugs out of threaded inserts. You see the 1, 2, 3, you can see 4 holes. See the threads? I think he's going to thread rebar into those. Pop out the plug. Yes, see that? There's been threads turned on the end of that rebar, and so that rebar will be twisted into those threaded inserts, and it is as if the rebar was continuous right across the beam, right through that column, right on out the other side. Threaded inserts are slick. And that's big bar. See, that is, what is that? That's 7 bar, 1.1 or 7 bar would be 7/8. Whatever it is in their designation, that's somewhere upstream of 1 inch. Now throwing a mat across there, right across the, look how far up it's chaired. It's just a top mat. Just a top mat in that floor, apparently. By that I mean the earlier slabs that we saw had a mat on the bottom and a mat on the top. It looks like there's only a top mat in this one. That is the tension side. Usually mats are in the tension side of the concrete because concrete only has compressive strength and steel gives the tensile strength. Cleaning off the edge, you're just cleaning off the scale and the flash and blowing off the top of that beam so the concrete adheres. And you're putting on some foam. Okay, those are forms. Those are concrete forms. Instead of lumber, they're a lost deck kind of form, nice and straight. Boy, that is new to me. Expanding foam. Oh, look at that. He's showing us how strong that is. Vibrating, consolidating. So when you vibrate concrete, you're bringing all of the particles of cement into contact with water. You are consolidating, getting rid of the air goes to the top. Consolidation of concrete is a big deal to get ultimate strength. But it's not always a big deal. Yeah. Wow. These boys, okay, that was a heavier rebar section in that area. Watch out, boys. Look at the haunches cast on that column. Lining up holes in the bottom. Look at that. Boy, no room for, what are those black they're spacers. Yep, those are leveling shims. High density plastic. Shoot those in with a laser so the column stands up straight. So they must be comfortable with the space between the rebar and that opening, right? I mean, they must be comfortable. There's something happens, another floor or something to keep anything from worrying about shifting. Line everything up. There. Look at that. There are no braces on those columns. They are just sitting on there, held vertical by those rebar dowels. Look how beautiful that is. All right. So I can see that economy of scale, if you were building these, let's say it's an apartment, and you were building 100 of these buildings, it would drive the cost per building down, right? I mean, that set of stairs is very expensive the first time, but by the time you've done 100 of them, the cost per unit is going down. That's all I can understand about this. But we're in summertime now, look at that. So we watched these things be cast when there was snow on the ground, and now we're watching it be assembled. The leaves are coming out. It's springtime. It's a warm day. Big crane. Big crane. This is good practice, by the way. You build your stairs before you build your second floor. Look at that. That's a fit. That is a fit. So see that these pick and eyes are different. Well, it's not a pick and eye at all. They're just hooked into rebar. They're hooked into the rebar system in that piece of form, just with hooks. Okay, there we go. They're grouting in between those columns. Pressure grouting with a hand pump. So those black wedges are the same type of material that are used on those little shim packs. Very strong, and then a non-shrink grout is pumped in there. Typical grout or concrete shrinks with hydration. Non-shrink grout holds its size for underneath columns and that sort of thing, and there's an expansive grout that's used in non-explosive destructive technology that will push rocks apart because as it gets hard, it gets bigger. We'll do a video on that sometime. Boy, that is bulletproof construction, no doubt. I see no troweling. I don't get it. Next level, same process. I wonder if that's the next day. I wonder how long they waited. Not very long, I'll bet. So they would have gone, they would have gone in and shot elevation on those little black shim packs on top of that lower column so that the top of these things all comes to the same grade in case they've accumulated a little height problem. There's no time to show all that. I don't see those same steel plates that we had down below. Yeah, there it is. Verifying alignment. No line of sight control. Boom. A building that is not vulnerable to fire. And it must be able to ride the earthquakes. Does Korea, let me ask you this, is Korea as prone to earthquake as Japan? It must not be, but it is on the ring of fire. So maybe, I guess these things would take it. Wow. I haven't seen a power trowel. Somebody explain that to me. Why is there not more effort being given to smoothing that floor up? Unless there's a finished floor that goes over this that compensates, tile or something. Wait, oh, it looks like they've been using whip trowels. Yeah, they were just using whip trowels, but man, how can that be flat? All right, roof's on. They didn't think that was interesting. Not part of the concrete. All right, there's the neighborhood. Just like that. 2 weeks? Is that what it said, 2 weeks? That's impressive. Anyway, so swinging these things in, they're so heavy and they're moving so slow, but you can't get a part of your body between the incoming concrete chunk and the situated concrete chunk. And I have a story about that. That finger right there was nearly cut off swinging in an arched culvert system that was put in for a company I was working for down by Ashland somewhere. And they were segments of a concrete arch culvert. The segments were 8 feet long and the span was like 8 or 9 feet and they were 6 or 8 feet high. Whatever the size, they were heavy. Big crane, bringing them out and setting them into 2 strip footings that had a block out to receive it. And we had set the neoprene shim packs and we were lowering these things in and I was signaling the crane and I had my hand resting foolishly with the fingertip going down into the block out to receive the edge of the arch. And I knew that the crane had to load about 3 or 4 inches above the level of the concrete, and I thought I was out of the way. So I was signaling, and I was watching, and it turned out it wasn't. That piece swung around there oh so slowly, and my finger was trapped between the piece and the concrete, and my finger took the whole inertia load, and then it swung away. And it was in a glove, and I thought, well, I lost that fingertip, and shock and numbness, and so I finished what we were doing, and I went up top to the boss, and I said, I think I may have just lost a fingertip. Now, I wasn't being tough, it was just numb, and my glove was turning red, and I took it off, and it was well and truly smashed. I don't know if you can see, but it's a little twisted, but it wasn't as bad as it could have been. It's still numb in there, the bone feels a little deformed, but I learned a lesson, an unforgettable lesson about miscalculating the clearance between a heavy load and a fixed object. It happens so quickly. These guys are so smooth. It just looks, the looks of that job site indicates to me that on-the-job accidents are scarce for this company in this country. I salute them for their efficiency. I salute them for the perfect fit on their precast members. And I wish somebody would explain to me why no one had a power trowel out there on those slabs. Thanks for watching Essential Craftsman, and keep up the good work.